insects dream. And, as we'll see in this video, we now even know what it is that insects dream about, which is incredible. And yet, should we be all that surprised? I mean, are we surprised about this because they're small? Well, no, that doesn't make any difference. They've got cerebral neurons, which are the foundation of conscious experience. So why wouldn't they have conscious experiences? Is it because they're invertebrates? Well, again, no. An invertebrate creature is just one who happens not to have a spinal column attached to a skull, because they've got different structures instead. But the nervous system is still there, and the cerebral neurons within the nervous system are still there, so it doesn't make any difference in terms of consciousness. And why do we tend to be so reluctant to acknowledge the consciousness of animals, even when the research showing that they're conscious has been around for so many years? With oysters, mussels and other bivalves, the evidence was first put forward in 1941 from Pierron and Artemiev and others, showing that the decisions of bivalves are coming from their cerebral ganglion, which is their skull-less brain, rather than from reflexes. So when an oyster decides to close, or when a mussel is building a defensive structure using byssal threads, these are all things which are happening because they're deciding to do it on the basis of their cerebral neurons in their cerebral ganglion. It's not reflex. With insects, the research evidence has been there for even longer. It's been there for more than 100 years. And yet, many people still resist acknowledging that insects are conscious. With fish, and with lobsters and other crustaceans, the evidence was there for decades before eventually the scientific establishment started to acknowledge that, yes, okay, they are indeed conscious. And just to put this in a little bit of context, this research paper was published a few years ago in the research journal Science, and it's to do with corvid birds, the crow family. And it says that whether or not consciousness can arise from the brain of a bird remains unknown. What's going on? I mean, it's kind of ridiculous. Well, perhaps the single biggest factor is that the founder of modern science and modern philosophy, René Descartes, managed to convince the scientific establishment that animals are merely unconscious machines, and that any evidence to the contrary could be written off as simply reflexive responses. Those ideas became so deeply ingrained in us for so many years across the centuries that even now, when we acknowledge the sentience of more easily relatable creatures, such as mammals and perhaps birds, we still tend to cling to the old unconscious machines point of view when it comes to the other parts of the animal kingdom. We have simply narrowed the range of our Cartesian thinking pattern, and we've simply narrowed the range of victims. According to Descartes' disciples, who used to enjoy nailing dogs and other live animals onto wooden boards, the screaming of a dog was no more significant, as Descartes himself said, than the creaking of a defective watch mechanism. There was no consciousness involved. But eventually there was a glimmer of hope. In the 1890s, the legendary biologist Auguste Forel established that the foundation of nervous systems is the neuron. And building on this, he published a paper in 1902 which was written in German, but translated, it's entitled "The Psychological Abilities of Ants and Some Other Insects." Forel rejected the old Cartesian ideas, and he didn't recognise the supposed ethical distinction between vertebrate and invertebrate creatures. and he instead proceeded on the basis that cerebral neurons are what sustain conscious awareness, and so if a creature has cerebral neurons, then why wouldn't they be conscious? And his experiments expanded on this and proved it. The neurobiologist Charles H. Turner then went even further, and, supported by experimental data and avoiding anthropomorphism, he talked about the rich inner life of insects. But when the work of Forel and Turner first came out, it hit a wall of resistance, because the Cartesian mindset was just so strong. But progressive biologists are now hailing them both as visionaries who were more than a century ahead of their time. Why? Well, because their ideas are being proven right all over again. For example, in the last few years, it has been shown that a whole range of insects and other invertebrates and fish exhibit signs of depression after negative events. And you can measure this by giving them choices and they choose in a more pessimistic or optimistic way. But they can overcome this if you give them antidepressants such as serotonin. Bees enjoy playing little games of football with little plastic balls. And the younger bees tend to enjoy playing more than the older bees, just as younger mammals tend to be more into playing than the older ones. And they're not doing any of this for any kind of obvious evolutionary advantage or getting calories or survival. They just seem to enjoy the experience of it. Fruit flies, meanwhile, like to go for rides voluntarily on little carousels, because again, they just seem to enjoy the experience. Fruit flies also like to drink alcohol, and when male fruit flies have been rejected by a female fruit fly, they drink more alcohol. And then he probably tells all his friends that he never liked her very much anyway. A new generation of scientists is proving what Forel and Turner knew all along, which is that consciousness comes from cerebral neurons, and that small animals, far from being merely reflex machines, are fully conscious individuals. But what about insects and their dreams? Well, less than 2 months ago, the Royal Society, which is the oldest and almost certainly the most prestigious scientific organisation in the world, it's international, not just British, the Royal Society published something which assimilated the results from 5 different research projects. And between them, these research projects established the following. When they are awake, the brainwaves of flies are in the same range as the brainwaves of awake human animals. And, again, like human animals, when they are asleep, during certain stages of sleep, they emit theta waves. Now, what's so special about theta brainwaves? Well, they are the brainwaves which are responsible for vivid dreaming. And where in the fly's brain, or cerebral ganglion, do these theta waves come from? Well, they come from the part of the brain which is not only responsible for visual attention, in other words, they're seeing a dreamscape, but also navigation. In other words, they are navigating through their dream world. Flies sleep, and when they sleep, they dream. And when flies dream, they dream of flying. The content of dreams have been revealed on a neurological level through studies on rats and on some types of bird, in particular finches. But this was the first time that the content of dreams have been revealed by research on invertebrate creatures. However, there is always a fly in the ointment, so to speak. When these experiments are conducted, The flies are, of course, held captive in a laboratory. They're not out in nature. And they are clamped in place by their heads. And electrodes are drilled down into their heads. They're still able to sleep through exhaustion or because sleep is induced, but this is still a terrible situation for any creature to find themselves. These experiments shouldn't be happening at all, however interesting the results of those experiments happen to be. And in fact, the results of the experiments show that these creatures are conscious individuals, so that just shows that the experiments shouldn't be happening in the first place. And so this raises the question, when flies sleep and they dream of flying, perhaps they're dreaming of flying away. And wouldn't it be appropriate if, when we get our first glimpse into the mind of an insect, we see them thinking about escaping from us? Until next time, remember that small animals matter. And thank you for watching.